Okay, well today we're going to be talking about proportions and similar figures, okay, in 2-8. Okay, the objectives for today is to find missing lengths in similar figures and to use similar figures when measuring indirectly. Okay, there is no academic standard for today. Okay, similar figures is figures that have the same shape but have different sizes. So what we're going to be talking about is that some figures have the same shape but different sizes. So, basketball, you have a women's ball and a men's ball, and that's different sizes but they're the same shape. Okay, so for an example here, essential understanding, and you want to write these triangles down as you go. But what we have here is that you can use proportions to find missing side lengths in similar figures. So we have triangle ABC is congruent to triangle FGH. And they're showing that here we have ABC and has side lengths 8, 10, and 12. And then we have FGH, which has 12, 15, 18 there. Okay, but they are the same shape. But clearly they're different sizes. Now you have to be very, very cautious because they're not always going to be to scale. So they may look the same size, but you got to go by what's labeled. Okay, so in the diagram we have triangle ABC is congruent to triangle DEF. Okay, because I couldn't put a triangle in your notes, you'll have to look at that and put that in your parentheses there. Draw a triangle ABC. That's how we name the triangle. We want to know what DE is. So the first thing we really want to do is we want to go ahead and label this. We'll call it X. We want to know what the side length is, and we'll call it a measurement of X. Well, in proportions, we knew we could set up two fractions. Okay, we could have a fraction equals a fraction. Now we talked about this, that we had to make sure that what was up here was the same or similar to what was up here. So what we're going to do is we're going to make a comparison of something that we were given with something that we need. Okay, so on this triangle we were only given 10, so that matches up with this 5. Okay, so they're the same. They need to be the same measurements, or sides that are similar. Okay, and we know that because this is really, we were talking about it being 90 degrees, so you might want to add that in. Now the side we were missing was AB compared to DE. Now they gave us AB, but we don't have DE. So we want to make those comparisons together. So we're going to compare these two measurements. So we're going to say over here, side AB, which is length 4, compared to side AC, which is length 5. So we're comparing the small triangle over here. And then over here, we have AB, which matches up with the DE. Okay, so those are the similar sides. So we're going to put X up top. So we have the same sides across from each other, just like we said we needed to have in the previous section. And then on the bottom would be the 10. Now we're back in the proportions. So we're just going to solve like we did proportions. We're going to cross products. Okay, do the cross products. So we have 40 equals 5x. And again, we could use a shortcut because the x is on top, and just multiply by 10, which is going to be 40 over 5 equals x anyway. So 40 divided by 5, we get 8. So side that we're calling x is length 8, but we need to say DE is 8 units. Okay, we don't have any units right now, so we'll say 8 units. And there's your how we solve for that one. Okay. Well, now we have this, and my little girl down here got shrunk. There used to be a little girl there. But it says the sun's rays strike the building. So we have the sun up here. It's striking the building and the girl at the same angle, forming the two similar triangles shown. So what we're going to do, just so we know, again, we're saying that everybody's kind of 90 degrees here, so that line there means 90 degrees if you didn't know. We want to know how tall the building is. Well, we know how tall the girl is. She was 5 feet. We know her shadow's casting 3 feet. We're able to measure those. Okay, we know the distance she's standing is 15 feet. Okay, through this information we want to know what this is. So we have two triangles. Okay, so we're going to do the proportions again. But again, we got to do the same things. Okay, so we're going to compare the girl here. She's 5 feet tall compared to the 3-foot shadow. The building is here. It's X feet tall and casts a 15-foot shadow. Okay, so the shadow's right here. So there's your proportion. The hardest part should be setting up the proportion. The simplest part should be to do the cross products. Again, you can use a shortcut here by now. I'm going to continue to show it with the steps. We're going to take 5 times 15. We're going to get 75. 3 times x, we get 3x. And then we're going to divide by 3, just like in 2-1. And we get 25 equals x, which means the building is 25 feet tall. 25 feet tall. And we need to make sure we use our units this time because we were given units. Okay? Well, we're going to stop there for now. We'll come back with the next video.